Okay, back again. Here we go. Question 2. Describe the following characteristics of the graph of the parent function. So let's go ahead and graph. We already know this is going to look like what? A V.
How do you have the
So absolute value, remember to find the absolute value. We go to map. We go to num. And where is the absolute value located? Yep, A, B, S, abs. Abs. Okay, so math, num, abs of X. Let's graph that and let's go through this again. Domain. Remember, domain's left to right. What's the domain here, folks? What is it?
Negative infinity.
Negative infinity to where?
Zero.
Positive infinity. Very good. What's the range? Do I include 0? To where? Infinity. Good. Intercepts. What can you tell me? So I have an x-intercept of what? 0. And I have a
Y-intercept of 0.
y-intercept of 0. Good. Symmetry.
X.
What's the symmetry?
Y-axis.
Y-axis. Now remember, it's whatever axis it's reflected in. And so this one, if you take it and fold it on the Y, it folds onto itself. What about continuity? Is it continuous? Yes. End behavior. What can you tell me about the end behavior? It's got 2 of them. So for negative infinity, where's it going? Yep, for negative infinity here, it's going to positive infinity because the graph is going up. Okay, limit as x, it goes to the right, it is also going to positive infinity. This one is both.
So it doesn't matter like what side it's on?
It doesn't matter what side it's on, it matters if it's going up or down. And then last but not least, increasing or decreasing. What can you tell me about the graph? It's increasing and decreasing, so now we need to find the intervals for each. So let's start with increasing and decreasing. Which one does it start with?
Negative infinity to 0.
For what?
For decreasing.
Decreasing, good. Negative infinity to 0 for decreasing. What's increasing?
0 to infinity.
Excellent job. Okay.
This is
so
everything we've learned.
that's everything we've learned this year.
Why
All
does it
combined
seem
into
easier?
one problem. Why it seems easier is because you've done this over and over and you've kind of built on. So, okay. Okay, the next thing we're going to talk about, I just want you to get this down, and then we will discuss more of this on Tuesday. Okay, but okay, we're going to talk about the transformations on Tuesday. Today, all we're going to be concerned with is exactly what we just got done doing. So, a transformation affects the appearance of a parent graph. A transformation affects the appearance of a parent graph. And then we have what's known as a rigid transformation or a non-rigid transformation. A rigid transformation just changes the position. So where is it located? A non-rigid distorts the shape of the graph. So it either makes it bigger, smaller, somehow just distorts it, shrinks it, stretches it. We will spend a good amount of time on each of those. By far the easiest ones are the rigid transformations of the two because all you're doing is moving that to a different location. The non-rigids are a little bit tougher. There you go. Does that work? So we're going to pick up on Tuesday with those transformations. Okay, but you're going to go ahead and start, okay, with some problems. Okay, so I'm going to go ahead and skip through my slides right here because this is eventually where we're going. Okay, and so your assignment, this is what you need to do. Now this is your assignment for the section. You should be able to do for me 2, 4, and 6. And those are problems that you have to do: domain, range, intercepts, symmetry, continuity, and behavior, and increasing and decreasing. So those are exactly like the two that we did in class. But on every part, 2, 4, and 6, you have to have every part of that problem. Okay? So we will continue with this on Tuesday.